All right, so we've tidied our data. We've hopefully gone from whatever data we started with into a format that is tidy. So we have one column per variable and one row per observation, and we know what our key variables are. That does not, however, mean that we are done. It is actually very common that you will even get a data set that is already tidy and still you'll have a lot of work to do on it because you're not going to be just working with any sort of tidy data set. You want to work with something that's ready for your particular analysis. How can you get things ready for the analysis that you want to do? There's plenty of data cleaning and manipulation to go before we are ready for that. We're going to be doing most of this with the dplyr package. So dplyr is a package in the Tidyverse. So once you load Tidyverse, you'll be loading dplyr as well. It is a package that uses a small set of verbs to very flexibly do all sorts of data cleaning and manipulation. Now, before we start getting into dplyr, I want to make one thing very clear. Please use it. If you've done R before, you have probably, but you have not used the Tidyverse for it, you have probably gotten used to doing some sort of data manipulation and cleaning with the base R code. Now, there's nothing necessarily wrong with it, but oh my God, is it harder? It's way harder. It's just much harder to do. And I know that some of you in my class, because I always get a student who does this, who's had some experience with R before, says, you know what, I already know how to clean data in R. I don't need to learn this new thing. Why are you making me learn this? And then they try to do all their homework using the base R data cleaning, and they mess it up. And they do it. They mess up because it's much harder to do and much easier to mess up on. dplyr is there because it is nice and easy. In fact, a number of the things that I'm going to show you in this series of videos, and I already have shown you, are here because they are the easier way to do things. It will be absolutely worth your time to relearn R data cleaning in R, doing it with dplyr, than not. You will save time. Even within the confines of a single class, it will be worth your time. I promise you. Please don't skip this one. Do please learn dplyr. Anyway, so dplyr uses a small set of verbs to very flexibly do all kinds of data cleaning and manipulation. Primary verbs are these: filter, select, arrange, mutate, group by, and summarize. There are, of course, other important functions in dplyr, some of which we will cover, including pull, which we already talked about briefly, case when, rename, and slice. There's a dplyr cheat sheet here that you can link to and check out. If you just Google dplyr cheat sheet, in fact, cheat sheet for a lot of different R stuff, you'll find a lot of them on the RStudio website. The dplyr cheat sheet in particular, I printed out and taped up above my office for a while I was still learning dplyr. It's good stuff. So, what are some of the things that we can do with dplyr? First, we're going to talk about subsetting data. So data subsetting is you have a data set, but you only want some of that data. You're going to subset the data. And so there are two main ways we can think about doing this. We can pick just some rows of the data, or we can pick just some columns of the data. So how can we do that with dplyr? Well, with dplyr, we can start by picking rows. We'll do that with the filter function. Filter limits the data to observations that fulfill a certain logical condition. It picks rows. We tell it a condition that is true whenever we want to keep the row, and false when we don't, and it will give us back just the rows for which that condition is true. For example, if we're working with that person year data that we talked about, let's say I just want to look at data for people who earn above 100,000 a year. So I say income is greater than 100,000. That will be true for anybody who has an income of 100,000 or above 100,000, and it will be false otherwise. And so if I say filter of my data and ask for income greater than 100,000, it will give me just the rows of data that have income above 100,000. So here's that joining that I did before, person year data to person data, and then I will type that to the filter, and I will ask for just the rows for which income is above 100,000. If you're familiar with pandas, this is sort of like query. And it will give us back just the rows with income above 100,000. So in order to do this, we need to create a logical condition. And learning how to make a good logical condition is a key component of not just using R, but coding in general. A lot of programming is based on writing logical conditions that check whether something is true or false. In R, if the condition is true, it returns true in all caps, which turns into 1 if you do a calculation with it. If it's false, it returns false in all caps, which turns into 0. By the way, there is an if-else function, but it's rarely what you want. I see students doing this all the time. If else, some sort of condition, true, false. This is redundant. Just condition by itself will return true if it's true and false if it's false. You don't need the if else part. Anyway, so some tips for constructing logical conditions. So some of them are pretty obvious. If you ask if A is greater than B, then it will be true if A is greater than B and false otherwise. If A is greater than or equal to B, if A is less than B, if A is less than or equal to B, and if A is equal to B. The double equal sign checks if something is equal. A single equal sign assigns something. You can also ask if A is not equal to B with A exclamation mark equals B. All of these will compare two numbers and check if A is above or below, et cetera, not equal, equal, all those things. Also, as I mentioned when we started introducing R, everything works by vector by default. So doing these sorts of comparisons in Python, I have found is actually really annoying because you have to like set up a loop to check if you have two columns and you want to check whether one column is bigger than the other column, you need to set up a loop to go through every single row one at a time. Whereas in R, if you have two columns of data and you ask a question like this, it will by default know that you want to do that, and it will compare each row one at a time immediately. So that's nice and handy, saves you a step. So most of the time, if you're creating a logical condition, it will just be one of these. You'll be checking if two things are equal to each other or greater than each other or whatever. There's also another really, really handy function for creating a logical condition, and that is in. %in% will check if this is in this list. This will check whether A is any of the values B, C, D, E, or F. This works not just for numbers, but also for text. So it's a good way to check whether something takes one of a certain set of values. Let's say, for example, that I was working with some employment data. I had an employment variable that was either employed, unemployed, not in the labor force. Maybe those are my three options. And I want to just look at people who are employed or unemployed. Well, I can say, is this employment variable in employed or unemployed? And then that would filter to just the employed or unemployed people, dropping the people who are not in the labor force. So here's how we can create all these logical conditions. We can also reverse those logical conditions by putting an exclamation mark in front of them. So for example, if I have, oops, there we go. So let's take a look at this data, the joined data here. Let's say I want to check whether you're in sales. So I'm going to say joined data. Let's limit it to January. So filter month name is in January or February. Great. So now I'm just looking at those two rows. Now let's say I want to get all the months that are not January or February. I'll just put a parentheses around that, add an exclamation mark. Now I'll get all the opposites. And there we have it. Right. We can reverse a logical condition by putting an exclamation mark in front of it. Although it's a good idea to use parentheses here so it knows exactly what it's trying to reverse. You can also chain together multiple conditions with the and, or use a bar for or. To see an example of that, let's take our data here, and let's say that we want things that are in January or February and are also the department is sales. All right, so I want sales in January and February. So I do run that. I can get both of those conditions at the same time. I get just January and February just in sales. And now let's say I want to do an or. I want everything. I want either to be January or February, or maybe sales in any month. So if I do that, I can use a bar for or, and it will give me back January and February for both of them, and sales any other time as well. So we can chain together logical conditions like that. Oops. All right, so that is filter. We can create a logical condition and then limit the data just to those rows. There are other ways to subset rows. Main one is slice. Slice picks rows just like filter. The only difference is that filter picks them based on a logical condition, whereas slice does it by row number. So for example, slice 1 to 5 picks the first 5 rows. Slice negative 103 will drop the 103rd row, and so on. This can be really handy, especially in data communications, because we might often want to do something like pick the top 5 of something, which I'll talk about how to do in a bit. So that's how we can filter rows. How can we subset columns? We want to pick just some of the columns in the data, and select is the function that will allow us to do that. It picks columns. You can do this by either name or column number. So it's not split into two separate functions like it is with filter and slice. Instead, select can do everything. You can also use the minus sign to unpick, to drop certain columns. I find in particular subsetting columns to be very annoying in Pandas. I think this is much nicer than the Pandas approach to doing it. Let's say our data has the column person, year, and income, but I want to pick just the person and year columns and get rid of income. How can I do that? Well, there's a bunch of different ways I can write this. I can say take the person, year data, filter that, send that to select, and pick just person and year. Notice there's no quotes here. I can, if I like, put quotes around the variable names if I feel like doing that. I can do columns 1 and 2, keep columns 1 and 2. I can say get rid of the income column, do minus income. And all 4 of these do the exact same thing. They give me back just the person and year columns. All right, so that is how we can subset our data. We can use filter or slice to pick just certain rows of the data. If we're using filter, we're going to need to create a logical condition that tells it how we are going to pick those rows. Especially if you're starting out, by the way, do check and make sure that your logical conditions are doing what you expect. Maybe use somebody creating a variable stuff we're going to talk about in the next in a couple of videos to see whether you're getting true and false in the places that you expect it to be before you try actually applying your filter. But create a logical condition, use filter to filter just to those rows, or use slice to pick rows by indices. Or if you want to pick just certain columns, you can use select to do that. Just a quick addition here. Something that is not part of subsetting data, but can be helpful when you are doing so, is the arrange function. Arrange is a dplyr function that sorts the data. That's all that it does. It sorts the data in whatever order you would like it to be sorted. You give it some column names, and it will sort the data by those columns. So this is why would you do this? Well, it's often a good idea, for example, to sort your data before you save it, for example, which makes it easier to look at and read, especially if you're going to maybe do some data communication, print a table. You want to sort that table in some way that before you print it out. You don't want it to be random order. It can also be very handy when you're filtering data in combination with slice. Let's say, for example, that you want to pick the rows with the top 5 highest incomes. Well, how can you do that? Well, we can arrange by the negative of income. This will arrange by income. And because it's the negative, it will sort from highest to lowest. And so now we've sorted by highest to lowest. We have the highest incomes at the top, and then I slice the top 5 rows off, and that gives me the 5 rows with the highest income. There are also some nice data manipulation tricks that rely on the position of the data. For example, there's the lag function as well, which says look 1 row above. So I can do something like sort by like arrange by date, and then use lag to say what things were like yesterday. That's another nice tip that you can use there. But arrange is another good thing that we can use when we are in combination with subsetting our data.